All right, so we'll have want to talk about the final exam. So again, I just sent out an announcement, but we will not have class on Friday, so this will be our last class of the quarter. It's been a pleasure being your teacher, and I hope you enjoyed the class. And I have to ask you a favor again, and that is to fill out your course evaluations if you haven't done so already. So please do take the time to fill that out. But yeah, I want to talk about the final exam. So final exam will be at the scheduled time. So for 9 a.m. class, it's on Tuesday, and the 10 a.m. class, which is this one, it's on Thursday. I will send out a seating chart, kind of like for the midterm exam, so be on the lookout for that. This is very important. You absolutely need a calculator for the final exam, so make sure you bring a calculator. It can be any calculator, graphing calculator, regular scientific calculator, but you definitely will want a calculator, okay? And then no note sheet for the final exam, okay? So midterm you got a note sheet, but for the final, no note sheet. So that's what we got. Okay, so these are the kind of the topics. Basically, each one of these headings will be a problem, and so you'll have some floating point number questions, okay? And so I'll ask questions based on some kind of miniature floating point system. So it'll be a lot similar to the floating point questions from homework 5, but I'll just change the number of exponents or the number of bits in the exponent or number of bits in the mantissa, and I'll kind of ask, questions based on that. Okay, so for this one, what students in the past have done, I not always, but sometimes I provide these descriptions of problems, and students in the past on Campus Wire would like make up their own kind of problems and share them on Campus Wire, and then people could answer them, practice answering, something like that. Okay, so that's something you can do. I think it's helpful to think of like what the questions might look like. All right, another question will be like manual root finding for some kind of one-dimensional function. So I'll provide some kind of arbitrary function, and depending on the algorithm, either I'll give you 1 or 2 starting locations, right? So secant method, you need 2 starting locations. The other, I guess bisection, you have kind of 2 endpoints, and the other ones you have 1 starting location. And then I'll ask you to manually perform 2 or 3 iterations of some kind of root finding method, okay? And obviously, if I give you x0, you'll find x1, and then you'll use x1 to find x2, and so on and so forth, okay? It could be any of the root finding methods that we covered in class. So we covered fixed point iteration, Newton-Raphson, secant method, bisection method for root finding. And then if Newton-Raphson method appears, I had to add this because a student complained. If Newton-Raphson method appears, you are expected to be able to figure out the derivative of the function, okay? And the function could include terms that are polynomials, some basic trig functions, log or exponent. I will not include hyperbolic trig or inverse trig functions because those derivatives are harder to remember. So I'm not going to put that, but the other ones, I think it's fair to expect that, yeah.
So do you know quotient rule as well?
Yeah, I won't do quotient rule, okay? But yeah, you should know product rule and chain rule. So you have that, okay? Okay. Yeah, I mean, quotient rule is just the power rule along with chain rule, right? Kind of, or product rule. So, but yeah, okay. So anyway, this is what you got. This is what you got here, okay? but yeah, a student complained like, "Oh, I didn't know we had to know how to do derivatives." I was like, "Oh, well, sorry, not a good reason." Okay. And then manual iterations of coordinate descent for some kind of two-dimensional function. So this two-dimensional function will pretty much just kind of have polynomial terms. I mean, it'll be like maybe x squared times y squared, or x, plus xy, or plus x squared, or equal to whatever, something like that, 2x, things like that. Okay, and you'll perform two complete iterations of coordinate descent. So I will give you some starting location, x0, y0, and then from there you will do coordinate descent. So, hold y constant, and then you'll have a function of x, and then you optimize x. Okay, now when you did coordinate descent in your homework, you optimized it using golden section search. Golden section search is an iterative algorithm, and it's not going to work in a thing. In a paper exam. So here you will optimize it, and you'll just use calculus to optimize your thing, right? So I mean, with a polynomial function, it's easy. You're going to do like find the derivative d of dx and set that equal to 0 and solve, and that should be simple. I guess you can add this. Sometimes it's helpful to have the quadratic equation. So I'll include the quadratic equation if that's helpful to figure out where something is equal to 0, or so negative b plus or minus square root of whatever 4ac. Okay, all right, and then so we'll I'll put that, and then you do coordinate descent, and I think that's okay. All right, and then you'll just kind of plot your kind of stair steps in on that thing. All right. Questions about either of these manual methods here? So this is where you'll want your calculator to be able to get your number that you plug into your next thing. Okay. There will be a question on kind of the Nelder-Mead method, and I included kind of like a separate worksheet for like some Nelder-Mead practice problems. Okay. And so here I've got some kind of function, all right, and I said if your initial simplex consists of these points, which of these points is w, which one is u. So for a Nelder-Mead method, you kind of you plug your things in, and the best performing point is u, and your worst performing point is w, and the Nelder-Mead method is all about kind of replacing that worst performing point with something that performs better. So that's a simple question, and then here I say, okay, what if I give you these points and they evaluate to here? Okay, based on this, where would your reflected point end up being? What would your extended point be? Your inside or outside contracted points, where are those locations? Okay, and for these, I also included solutions. I think. When I created these solutions, I think I did these correctly, but there's always a possibility, and it happens, and it's always a little embarrassing, but I make mistakes too. So if I made a mistake in my solutions, just put it on campus wire and say, I think you made a mistake or something, and then maybe your classmates will agree or something, and then we can kind of correct it, and I'll fix it for the future. But I hope I did it right, but I'm always I'm not saying I could have made a mistake there. Okay, and then or it could be something like if you had these points, what would the algorithm do? Would it replace w with r, or attempt an extended point, or attempt a contracted point, or something like that? Okay. So these are the kinds of questions you might see related to Nelder-Mead. I probably wouldn't put every single one of these questions on there, but maybe take a selection of some of the questions from the Nelder-Mead kind of practice handout there. All right, so that's kind of manual solving of some of these algorithms. And then, and this is always a little bit of a risky thing to do in an exam, but I'm going to ask you to write a few lines of code by hand, okay? And you'll have to do either, well, actually probably both of these things, a randomization test and a bootstrap test. I feel okay doing this because, if you think about how many lines of code does it take to run a randomization test, it's not going to be like more than 10 lines of code. Okay, so it's you set up you set up your data, your population, where it has your population of values. You set up a for loop. You run sample. You put them into separate them into two groups. Find your difference. Okay, and that's basically your lines of code there. So I'll provide some kind of problem where there's a description of the data. Now this data could be categorical or the data could be numeric. So you've seen a couple examples. So categorical data we had in the lecture notes, that was like the yawning and Mythbusters. Okay, and then you had a numeric example in your homework, which was the how long does it take for someone to back out of their parking spot? I don't know. I was surprised because when I'm like in a parking spot and I see somebody waiting behind me, I feel like the pressure to like hurry up. But I don't know. There's like, I guess some people are like, take my time. Okay. So anyway, I'll provide some kind of description, and then you'll have to set up a hypothesis test. Okay, and the question, all right, so based on how this question is written, that's going to affect what your hypotheses are. So is there evidence that a seed yawn increases the chance of a person yawning? So you'll have a one-sided where you want to see if the seed yawn proportion is greater than the control proportion, okay? Or is there evidence that drivers take longer to exit their space if a person is waiting? So that one's also one-sided, and you want to see if the value for exiting when someone's waiting is greater than the time, the average when somebody is not waiting, okay? Or, the question could be like, is there evidence of a difference, which would be two-sided or non-directional, and you'd be interested in either of these kinds of things, right? So you'll have to write kind of what the appropriate hypotheses are. You'll write the code to perform the randomization test, and when obviously, your code needs to be legible and clean. And, overall, it should be syntactically correct. If you have like a small kind of mistake in there, but we understand what you're doing, I think we're pretty forgiving of that. But, the part where students frequently mess up, okay, and this is true for both the homework and any kind of these things, is like, how do you calculate your empirical p-value? Okay, and this is and when I say mess up, this is not the problem with messing something like this up isn't that you're going to get an error. Okay, it's just that you're going to get a number, but that number is wrong. Okay, and that, I would say, that's like a more dangerous thing than like writing a line of code that gives you an error, because then you go, oh, I know something went wrong. But if you write this wrong and you get a number, but it's but you did it wrong, then that's a different problem. So when you write the line to figure out your empirical p-value, you need to make sure are you using the greater than sign or the less than sign? Okay. Are you using absolute value or not, right? So these are things that you need to be aware of, right? So for two-sided test, you would use the absolute values, and depending on how the question is written, okay, you want to make sure the distribution of randomized differences that I generated. Am I going to use a greater than sign or a less than sign versus my observed difference or whatever it is? Observed test statistic there. Okay, so I would say this is the line that we're going to check kind of closely to make sure you get that right. Okay, and then obviously you can't run the code because you've written it by hand. But I'll have a line that says, let's pretend we ran the code and our empirical p-value is 0.02. All right, and what does that mean? Okay, and so I want to know like. Not just like we reject the null hypothesis, but what does it mean to reject the null hypothesis? It means we have our data provides evidence of blah, 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 or something like that, okay? So that's the randomization test, and then there will also be a bootstrap test, pretty much just very, very similar to the randomization test. I'll provide some kind of description, the data, question that requires a hypothesis test, and I'll say, perform a bootstrap test, okay? And that bootstrap test could be a parametric bootstrap test. It could be a non-parametric bootstrap. So if it's parametric, you'll sample from, say, like R norm or some kind of random distribution. Non-parametric, you'd resample your values, okay? I will not ask you to use package boot. However, you are allowed to use package boot if you are comfortable using package boot. So I didn't require it in the homework, but I do have notes on it. And so if you want to use library boot and you want to write your statistic function where it takes the data and the indices and it resamples your data accordingly, you're allowed to do that. You're not required to, okay? And I will tell you whether I want you to do a parametric or non-parametric test, and then and you'll write your code. Make sure you have a line to calculate your empirical p-value, and then I'll say, hey, what, kind of just like the randomization test, we'll say, let's pretend you get this p-value, empirical p-value. What is the conclusion there, right? So that's the randomization test and bootstrap test. A little bit of writing code by hand. Okay, and then lastly, I'm going to have a handful of conceptual questions. And this will just be from miscellaneous topics from after the midterm exam, okay? The questions, in my opinion, are simple enough to be answered with one sentence, okay? Or at least a very short response, and actually that's preferred as your professor who has to grade your exams. It's much more preferred if the answer is short and correct than long and wrong, because it's sometimes I think students, they see something and they're just like, I'm going to write every single thing I know, and I hope one of those sentences is correct somewhere in there. But it's not a good not a good strategy, I would say. Okay, so an example question that you might see, obviously I'm not going to put this on there, will be something like, when is a fixed point an attractive fixed point? Okay, and the answer is when you take the derivative. Here, this is my sentence. Okay, point A is an attractive fixed point if the absolute value of the derivative of the function at A is less than 1. That's when it'll be an attractive fixed point. And yeah, so you'll have questions kind of like this. That's kind of what you can expect to see for the final exam. Any questions on how this works? Okay, so again, make sure you bring a calculator. I can't let students borrow each other's calculators. That's it's too risky. So that's that. Okay, yeah, question. I don't think so. I mean, inevitably, so, in a room of 80 students, there will probably be 8 students at the end of the full 3 hours, okay? But, I could give you 10 hours and there'll probably still be, several students who stay all the way to the end. So, it just depends on the, and that's fine, that's, you are entitled to your allotted time. Okay, so that's it. Okay. Anything else? Yeah.
Are you gonna have normal office hours?
No, I don't do office hours during finals week. I don't know. I'll just say I learned my lesson. So, I'll have office hours on Friday and Saturday, and then because I always, I don't know if you guys know, but I always had office hours Saturday mornings, 10 a.m. It's been there, so that'll be kind of the last office hours, and then starting Sunday, no office hours after that. Okay, yeah.
Will the Saturday office hours continue next week?
Yeah, I've generally done Saturday office hours, like every Saturday for, I don't know, since the pandemic, I think. Yeah, and it's fine. Half the time I'm eating breakfast or something. Okay. But yeah, yeah, I mean, obviously some Saturdays I take off, but that's that. Okay, I'm going to go ahead and I'm going to just end the recording here. So if you're watching the video, that's it. You missed out on my bonus talk here, and there's no lecture view quiz, so that's that.